Once again, how do we make mountains? A few different ways, but the simplest, easiest way to showcase is two plates colliding with each other. One plate's going to be forced underneath the other, and thus we're going to get something called folding or subduction, in which we have landform change. And so we'll go ahead and showcase that as the pink plate converges with the yellow plate, which we see here as the plate's getting closer and closer and now colliding with. And the pink plate, because it's heavier, is being forced underneath the lighter, less dense yellow plate, forcing it then upward. And so eventually this is going to form a more rugged terrain, in which we see here now a mountain's been formed from the plate collision. And this is how the Appalachian Mountains formed. However, they formed a long time ago. Here we have a map showing 360 million years ago. For the purposes of this discussion, a long time. We do already have the Canadian Shield formed, but the Appalachian Mountains, compared to a lot, especially the western coast in the western United States, here we have a very old landform in which it's been around for a long time. Well, how did it form? Well, it's formed a few different times. We call these moments in which mountains have formed from plates colliding or continents colliding. We call them orogenies, Orogenys. Sounds much more risque than maybe what it is. But what we have essentially different times in which plates are colliding with each other, and so the Appalachian Mountains have had several different plate collisions. So way back when, they were colliding with the African and the European plates. And so we see the Atlas Mountains in Africa, also the Scottish Highlands there in Europe, and the Appalachian Mountains have actually had different moments in which they all formed, were actually essentially all created from the same orogeny or the same mountain building event. So what I'm going to do is I'm not going to play this in time, and so we can see faintly the United States as they are today superimposed on this this visualization or model of what the world looked like 345 million years ago. And this is a time in which we have a often used geographic term, Pangea. Essentially, the world was one massive supercontinent. The various continents of the world were all essentially together in a sense broken off from Africa and slowly drifted away. So 315 million years ago, Africa and the southeast part of the United States are one and the same. And we see this here now shown with the labels on the map, with the Appalachian Mountains, or what would become the Appalachian Mountains, are clearly shown here in this rugged feature. Where only 290 million years ago, 275 million years ago, and now 260 million years ago. And so at this time, the Appalachian Mountains were big suckers. We're talking very similar in size to the largest mountains in the world today, the Himalayan mountains. So at the time, they were young, they were youthful, they were teenagers. So essentially what this was is two plates colliding with each other before they started to drift apart. So the Appalachian Mountains were being formed. These were the growing years. These are those years in which they were developing. However, soon the development's essentially going to stop as these mountains over time get smaller and smaller and older and older. In a quick 411, whenever you're trying to determine, okay, what is a young mountain, what is an old mountain, just look at them. Young mountains typically are going to have taller features, going to be more angular, going to have sharp angles, whereas older mountains are going to be more rounded down, more like hills. And so if you've been to the Rocky Mountains, if you've been to Colorado, you know those very tall, conical shape, very triangular shaped mountains, whereas down in the Smoky Mountains, down in Tennessee and North Carolina, in West Virginia, they're more like rolling hills. Now, trust me, coming from Indiana, they're still, they're still big suckers. But over time, weathering, erosion, years and years of all that has left its toll as far as slowly removing the large, big, huge features that once were here. And this is still going to continue to this day, in which these mountains are only going to get older and over time smaller and smaller and smaller. Now, as we start to put this in motion, this is only 245 million years ago, I want you to start to look at the divergent plates, and that essentially that North Atlantic Ocean, it separates. And as it separates, United States, North America drifts off from Africa and drifts farther away from Europe as Canada and Greenland start to all separate from each other. 230 million years ago, 210, 195, 180, notice the divergence, separation, which we also call rifting. And now the Atlantic Ocean is starting to form. You're starting to see that bigger water body separate and get bigger and bigger and bigger over time. And now, relatively recently, 85 million years ago, the Appalachian Mountains, on this particular image, you can barely see them compared to the Rocky Mountains in the West Coast, which are still forming, much younger and thus much more rugged. They're on the western side of the United States and Canada.